It was in this primordial chaos that the planets we know today were forged. They grew by accretion, sweeping up smaller bodies in their gravitational embrace. But this process was not always gentle. Sometimes the encounters were not mergers, but devastating, planet-altering collisions. This is where the leading hypothesis for Uranus's condition takes center stage. The theory posits that a massive object, perhaps an Earth-sized protoplanet, careened through the young solar system and delivered a cataclysmic, glancing blow to the nascent Uranus. This wasn't a head-on impact, which might have shattered the planet entirely. Instead, it was an oblique strike, a cosmic haymaker that transferred an immense amount of rotational energy. The force of this impact was so profound, so utterly titanic, that it literally knocked the entire planet over, torquing its axis of rotation until it lay nearly parallel with its orbit. The fallen giant was born from a single, universe-shaking moment of violence. Computer simulations that model this ancient impact show how such an event could not only explain the 98-degree tilt, but also other Uranian mysteries. For instance, the collision could have churned the planet's interior, mixing its core materials of rock and ice with its upper layers of hydrogen, helium, and methane. This might explain why Uranus, unlike its gas giant cousins, radiates so little internal heat into space. Its primordial heat may have been catastrophically expelled during the impact. The event didn't just change its orientation, it fundamentally reshaped its internal structure and its thermal destiny. The debris from this colossal smash-up wouldn't have just disappeared. It would have been thrown into orbit around the wounded giant. Over time, this cloud of shattered rock and ice could have coalesced to form the system of moons and faint dark rings that we see around Uranus today. This means that Uranus's entire satellite system might be the children of that ancient cataclysm, born from the very event that so profoundly altered their parent. The planet, its tilt, its moons, and its rings, all may be interconnected pieces of a single violent story, written in the language of gravity and collision. The consequences of this epic tilt are not just a historical footnote. They are an ongoing reality that shapes every aspect of the Uranian environment. Let's journey to one of its poles during its long, 21-year summer. For 2 decades, the sun never sets. It simply circles high in the sky, bathing that hemisphere in constant, unrelenting sunlight, albeit weak sunlight. There is no day or night, only a perpetual twilight caused by the sun's immense distance. An observer standing there would experience a day that lasts for a quarter of their lifetime, a season of endless light before the long, dark winter inevitably arrives. Meanwhile, on the other side of the planet, the opposite pole is experiencing a winter of equal, terrifying length. 21 years of absolute darkness and unimaginable cold, a polar night from which there is no escape. The temperature plunges to depths we can scarcely imagine, a profound cryo-sleep. And the equatorial regions? They experience a bizarre, rapid cycle of day and night as the planet rolls along its orbit. During the equinoxes, when the sun is directly over the equator, the planet spins normally relative to the light, giving it a day-night cycle of just over 17 hours. It's a world with 2 completely different climate regimes. You might expect the sunlit pole to be significantly warmer than the dark one, but observations have revealed another Uranian puzzle. The temperatures across the entire planet are surprisingly uniform. The dark pole is nearly as warm as the one basking in decades of sunlight. This suggests a powerful atmospheric dynamic at play, a global weather system of immense scale that redistributes the sun's energy from the light side to the dark side. Massive planet-spanning storms and supersonic winds must be raging in its blue-green atmosphere, acting as a planetary heat exchange system to balance the extreme solar inputs. This creates weather patterns unlike anything seen elsewhere. During the long polar summers, colossal storm systems, some the size of continents on Earth, can form and rage for years. Then, as the planet approaches its equinox, the changing solar energy can trigger even more violent weather across the entire globe. The extreme tilt of Uranus doesn't just give it long seasons, it creates a meteorological laboratory for the most extreme and bizarre atmospheric phenomena in the solar system. It's a world perpetually off balance, its climate forever trying to catch up with its own lopsided reality, a beautiful, chaotic consequence of an ancient cosmic wound. Come with me to the edge of our solar system, to Pluto, king of the Kuiper belt. This realm of profound cold and deep mystery was once thought of as a simple, inert ball of ice and rock. But in 2015, NASA's New Horizons spacecraft revealed a vibrant, geologically active landscape. Among these alien features, evidence of volcanoes that erupt with ice, slush, and frozen gases. This concept, cryovolcanism, challenges our very definition of what a volcano can be. Scientists theorize pockets of a subsurface ocean kept liquid erupt when it finds a weak point in the crust. It doesn't erupt with fire, it erupts with cold. This is not the geology of Earth, but a testament to the fact that even in the coldest corners of our solar system, the universe finds a way to be dynamic. Let's zoom in on Right Mons. It's immense, about 150 kilometers across and 4 kilometers high. Its most telling feature is the vast, deep caldera at its summit. This structure shouts volcano. Scientists estimate Right Mons is composed of thousands of cubic kilometers of cryolava, suggesting sustained geological activity. It implies a long-lived internal heat source. The leading hypothesis points to a subsurface ocean, kept liquid by ammonia and internal heat. This hints at habitability in the universe. The real action might be happening deep inside, in hidden oceans warmed by internal heat. The number of potentially habitable worlds may be vastly greater than we ever dared to imagine. Pluto isn't alone in its icy eruptions. Cryovolcanism is a recurring theme in the outer solar system, seen on Neptune's moon Triton and Saturn's moon Enceladus, where plumes of water vapor erupt from its south pole. Cassini found water, salt, and complex organic molecules, hinting at a subsurface ocean.